So as we continue through the journey of the components of a LoRaWAN network, Luke talked about the devices. Frank just gave some great insight into the gateways, and now I'd like to spend just a couple of minutes focusing on the LoRaWAN network server. So we can jump to the next slide, Karine. First of all, so what is a LoRaWAN network server and why is it needed in your network? As I mentioned before, the network server is essentially the brains of your LoRaWAN network. It acts as the central management hub of the network as it coordinates the communication between the hardware, so the devices and the gateways, and your application. One of the primary roles of the network server is data filtering, processing, routing. So when devices are transmitting packets into the network server is responsible for processing these packets. Like I mentioned, the first thing it's going to do is it's going to evaluate whether or not the message that's being received is coming from an expected device in its network. And if so, it will process this packet into the network and eventually on to the application. And if not, it'll simply just throw it away. So all of the data being transmitted by any LoRaWAN device will first land in the network server for processing before carrying on to the application. The network server also plays a very key role in the security of the network. So this is where all of your authentication and encryption is managed. A LoRaWAN packet by default is encrypted, meaning that if you were ever to intercept a LoRaWAN packet prior to it reaching the network server, there's really nothing that you can do with it. And the network server actually holds all of the keys to the devices in the network, meaning that when a network server receives a packet from an expected device, it's going to evaluate its database to check to make sure that the message that was received is coming from one of its devices. If so, it will verify that it has the appropriate key to basically unlock or decrypt that packet, and only then will the message be accepted into the network and decrypted. The network server also plays a very key role in gateway and device management. I'll talk a lot more about gateway management in a moment, but from a device perspective, the device configurations are managed in the network server. So let's say, again, I gave an example earlier, but let's say you had a tank monitoring application and you had a tank monitoring sensor that was transmitting tank levels into the network every hour, but you wanted to receive this data more frequently, say every 15 minutes, you would manage this configuration in the network server, and then you would push that configuration down through the gateway to tell the device, okay, I want you to change your reporting threshold. This is where you can also set up things like threshold, like event-based thresholds and alarms to force a packet based on a certain event happening. So, for example, like a leak being detected for a leak detection use case, or when an asset starts moving, or maybe an employee is wearing a LoRaWAN connected safety device and that employee falls down, and you want to trigger an uplink into the network based on those sorts of scenarios. All of that, again, can be managed in the network server. And then there's also a great deal of network monitoring capabilities managed by the network server as well. So the network server provides data about the performance of the network and the health of the entire network, including tracking key metrics such as like packet delivery rates, signal strength, signal quality, those sorts of things. So we can jump to the next slide. So Tektelic, as I mentioned earlier, we have a network server as part of our portfolio, which is called Kona Core. Kona Core is used by many of our enterprise customers who are deploying their own LoRaWAN networks and is designed for high performance, reliability, and to reduce the overall total cost of ownership of our network operator partners. It's built on a high availability platform that scales to tens of thousands of gateways and millions of sensors to meet the demands of the most challenging networks. So we can jump to the next slide. Tektelic really takes great pride in ensuring that all of the LoRaWAN network components that we offer, as I mentioned before, are completely interoperable with the LoRaWAN ecosystem. And this, of course, also extends to our Kona Core network server as well. So we have open support for any third-party LoRaWAN gateway, any LoRaWAN device, ensuring that we're never, ever locking in our customers and empowering them to grow and scale in the LoRaWAN ecosystem. Kona Core has an open API to integrate seamlessly with almost any IoT platform or application, just like the one that Luke will speak about here in a moment. And it's most commonly, the Kona Core is deployed in the cloud, but it can also be deployed physically on premise, on site, and a physical machine as well, for the use cases that require that sort of extra level of containment and security. And it's very, very, very reliable and highly available. Between all of our customers and partners using Kona Core today, there are tens of thousands of gateways, millions of devices connected, and we're achieving over 5 nines of availability, ensuring that our customer networks are always operating without interruption. Now, earlier, Frank walked you through the gateway story and Tektelic's portfolio specifically, and I'd like to just take a minute to talk about our Kona Element Operations, Administration, and Management Server. So I mentioned earlier on in the presentation that Tektelic's goal is to empower our customers to be able to deploy and manage LoRaWAN networks for the lowest total cost of ownership over the duration of the full deployment. So typically that's over 10 years. And there's really no better way to showcase this than with this tool, Kona Element. Kona Element is essentially a remote gateway management tool that allows you to remotely manage, configure, provision, and monitor your gateways from literally anywhere in the world. Kona Element even includes performance indicators like spectrum analysis, spectral scans for real-time visibility into the performance of your network. Now, all of these remote management capabilities are included in Tektelic's network server as well. But like I said, we want to ensure the success of all of our customers, no matter which piece of the LoRaWAN puzzle we are supporting them with. And for this reason, we make all of these features available to any customer who are using our gateways with any LoRaWAN network server via the Kona Element tool, which is a standalone solution that, like I said, can be used with any LoRaWAN network server. A single site visit to, repair a gateway or troubleshoot a gateway is going to cost way more than you ever paid for the gateway in the first place. So having the ability to monitor, manage your gateway completely remotely is absolutely essential to ensuring that you're operating a cost-effective LoRaWAN network. Tektelic, we've been in the LoRaWAN space for around 10 years, and we've been supporting LoRaWAN projects for this entire time. And we know that the actual cost of the gateway in a LoRaWAN network deployment is really only about 5% or less of the total cost to deploy, manage, and operate the network. So if we provide tools and solutions to our customers like this, which will help them reduce that other 95%, we believe that we're doing our part to promote the mass adoption and scaling of IoT and LoRaWAN. Okay. And then finally, I'd just like to give a little plug here to a very valuable tool that Tektelic has recently released called Kona Radiant. Kona Radiant is a very valuable RF coverage mapping tool that's offered by Tektelic, but it has been designed very specifically for LoRaWAN networks, which is a really sort of valuable thing. It greatly simplifies the process of network planning and deployment. And really all you need to do is deploy a gateway along with a handful of sensors, and you can assess RF performance in real time almost immediately. So this allows you to quickly identify the optimal location to deploy your gateways, your sensors for the best coverage and the best reliability and performance of your network. One of the best features of Kona Radiant is really how quickly it can be deployed. You can set up the kit in just a few minutes, making it incredibly simple to conduct coverage testing, which can sometimes be a complex or challenging task. Just to give a quick example, about 6 weeks ago, we hosted a customer event in Amsterdam at a hotel in central Amsterdam, and we did a live demo of this Kona Radiant tool while we were there. And literally, we plugged in the gateway in the room where we were hosting the event. Our president, Roman, actually had a little bag of about 10, 12 devices. He ran around the building, deploying them all through the hotel. And within minutes, we were able to showcase a real solution of, how each of those devices were performing, the connectivity, the packet success rate, the RSSI, most importantly, the signal quality being received by each of those devices, or being received by the gateway from each of those devices. So once you have Kona Radiant deployed, we have a very simple application that you can see kind of in the screenshot there that provides real-time monitoring, allowing you to see sort of the live data about those metrics I just mentioned, packet success rates, signal strength, signal quality from each of your devices. And it's delivered in a very sort of user-friendly interface so that kind of a color-coded interface, so you can very quickly see which gateways are performing, or which devices are performing well, which devices may need to be optimized in terms of their placement, or if another gateway needs to be added, those sorts of things. So it's a very kind of valuable, simple to use tool that's going to help you be more effective in managing your deployment and your network. So